Welcome to Intelligence Gateway.
Module 2, Architectural Patterns. Architectural patterns are predefined, reusable solutions to common architectural problems that software engineers face. They provide a framework or blueprint for designing software systems that are flexible, scalable, and maintainable. Architectural patterns help to ensure that the resulting systems are well-structured, modular, and efficient. They are often used to solve complex problems that require a high degree of architectural expertise, and can be applied across a wide range of software systems, from small applications to large-scale enterprise systems. By using architectural patterns, developers can reduce development time, improve code quality, and increase the maintainability and longevity of their applications. Overview of architectural patterns. Architectural patterns are design solutions that provide a structured way of solving recurring software engineering problems. They provide a framework for designing software systems and help ensure that the resulting systems are flexible, scalable, and maintainable. Here's an overview of some common architectural patterns. 1. Client-server pattern. This pattern divides the application into two parts: a client component that interacts with the user and a server component that handles the business logic and data storage. The client sends requests to the server, which responds with data or actions. 2. Model View Controller, MVC, pattern. This pattern separates the application into three interconnected components: the model, data, and business logic. The view, user interface, and the controller, handles user input. This separation of concerns helps make the code more maintainable and reusable. 3. Layered pattern. This pattern divides the application into a set of horizontal layers, each of which is responsible for a specific set of tasks. This separation of concerns helps to modularize the code and make it more maintainable. 4. Microservices pattern. This pattern breaks the application into small, independent services that communicate with each other via APIs. This allows for greater flexibility and scalability, as well as easier maintenance and updates. 5. Service-oriented architecture, SOA, pattern. This pattern focuses on creating reusable, loosely coupled services that communicate with each other via a common protocol. This allows for greater interoperability and agility, as well as easier maintenance and updates. Layered architecture. Layered architecture is a software design pattern that separates the application into a set of horizontal layers, where each layer is responsible for a specific set of tasks. This approach provides a clear separation of concerns and helps to modularize the code, making it easier to maintain and modify. Typically, a layered architecture consists of three main layers: presentation layer, business logic layer, and data access layer. The presentation layer is responsible for handling the user interface and user interactions. The business logic layer contains the application logic and rules, and the data access layer handles communication with the underlying data storage system. This layered structure allows changes to be made to one layer without affecting the other layers, making it easier to modify or replace individual components of the system. It also makes the system more scalable, as additional layers can be added as needed to handle increased complexity or functionality. Layered architecture is widely used in enterprise systems, web applications, and other complex software systems where a clear separation of concerns is essential for maintainability, scalability, and flexibility. Client-server architecture. Client-server architecture is a software design pattern in which the application is divided into two parts: a client component and a server component. The client component is responsible for presenting the user interface and handling user interactions, while the server component manages the business logic and data storage. In a client-server architecture, the client sends requests to the server, which responds with data or actions. The client and server communicate with each other over a network, typically using a protocol such as HTTP or TCP/IP. This architecture provides several benefits, including scalability, maintainability, and security. By separating the application into two components, it is easier to scale the system to handle large numbers of users. The server component can be run on a separate machine, allowing it to be optimized for performance and security. Client-server architecture is commonly used in web applications, where the client is a web browser and the server is a web server. However, it can also be used in other types of applications, such as mobile apps, desktop software, and enterprise systems. Microservices architecture. Microservices architecture is a software design pattern in which an application is divided into small, independent services that communicate with each other via APIs, application programming interfaces. Each service is designed to perform a specific business function and can be deployed independently, often using different programming languages, frameworks, and data storage technologies. In a microservices architecture, each service is responsible for its own data storage and processing, and can be scaled independently based on its workload. This allows for greater flexibility and scalability, as well as easier maintenance and updates. It also enables developers to work on smaller, more focused components of the application, which can improve productivity and reduce development time. However, implementing a microservices architecture requires careful planning and design. The complexity of managing multiple services and APIs can be challenging, and there may be additional overhead associated with communication between services. Additionally, the architecture can be more difficult to secure than a monolithic application, as there are more points of entry for potential attackers. Microservices architecture is commonly used in large-scale, complex applications, particularly those with high traffic and frequent updates, such as e-commerce sites and social media platforms. It is also gaining popularity in the enterprise world, where it can be used to modernize legacy systems and improve agility and scalability.
Thanks for watching. For more information, like, comment, and subscribe our channel.